So this is the answer key for today's worksheet. Number 1 says find an equation of the tangent to the graph of y equals f prime of x at x equals 3. Well, this has a twist because now it wants the tangent to the graph of y equals f prime. So f prime of x is 4x cubed. We're looking for the line tangent to 4x cubed when x equals 3. So then we do f double prime equals 12x squared. So when x is 3, we plug in 3, we get 108. So here's our slope derivative. And when we plug in 3 for y, so over here, 4 times 3 cubed, we also get 108. And so here's the equation of our tangent line. Y minus 108 equals 108, x minus 3. Okay, these are the solutions for 2, 3, 4, and 5. Here we're looking for the second derivative. Here we're looking for the third derivative, so just do it 3 times. Remember, if we have something times something, we use our product rule. And if there's a function divided by a function, we use our quotient rule, low d high minus high d low over low low. You can pause the video to look at these steps. Here we have the velocity of a particle moving along the x-axis is given by, and they give us the velocity function. For t is greater or equal to 0, which of the following statements describes the motion of the particle at t equals 1? Well, this is the calculator section, number 86, and so I plug this right into the calculator. It wants to know the motion at t equals 1. So zoom in where you can get a clear picture of what's going on when t is 1. And it's right here. You can see the velocity function is increasing. Since velocity is increasing, then the acceleration is positive and it's moving to the right. 88, the first derivative of the function is defined by, and they give us the first derivative. They want to know when is f increasing. Well, when I plugged in the first derivative, I noticed it was all positive. When my derivative is all positive, when my slope is positive, my function is increasing. So it's all positive, so it's increasing everywhere. Choice C. 89, they give us a table, and they tell us that it is continuous for these values 0 to 13, which means there's no skipping in between. So what is the fewest possible number of times f of x equals 4? Well, between 3 and 4.5 is a 4, between 4.5 and 3. There's no 4 between 3 and 2.5, but then again between 2.5 and 4.4. So because it's continuous, then the intermediate value theorem guarantees that 4 will be in between those two numbers. So there's 3 times when this happens. The velocity v in meters per second of a certain type of wave is given by, and so here's our velocity function, where h is the depth in meters of the water through which the wave moves. What is the rate of change? So we're looking for the rate of change of this velocity function. Once I see rate of change, I know that's a slope or derivative. And so I take the derivative of 3 radical h, which can be written as 3h to the 1/2. So I bring the 1/2 in front, h to the negative 1/2, I plug in 2, and that gives me choice C. Remember, you see rate of change, derivative, slope. Number 77, I have a table. It says let f be a differentiable function with selected values. What is the average rate of change? Well, it's differentiable, therefore it's continuous. It's looking for the average rate of change. So again, I use my slope formula between these 2 points. So negative 20 minus 5 over 10 minus 0, and we get choice B. 79, another table, differentiable functions, f and g, their derivatives at x equals 0. If, and they give us this quotient, a function divided by a function, what is the value of h prime of 0? Well, I got to find the derivative of a quotient. So I do low d high minus high d low all over low low. And I use the table, right? So low, that's g. So that's just g. 2. Derivative of high, derivative of f of x is 4. And continue to plug in. 83. A particle moves along the x-axis so that its position at time t is greater than 0 is given by x of t, and the derivative of x with respect to t, well, this must be my velocity function. The acceleration of the particle is 0 when, so they're asking for acceleration, but they give us velocity. So I took the derivative of velocity. So I got negative 40t cubed plus 18t plus 8. I plug that into y equals. Here it is in y equals. They want to know when the acceleration is 0. So I use second trace 0 to find this value. And that's when my acceleration equals 0. One more, the graph of y equals f of x on the closed interval is shown above. Which could be the graph of f prime? Well, here's the graph of f. Here f is decreasing. Where f is decreasing, my slope or my derivative is negative up until here. And then this is increasing, so my derivative is positive. So I know I'm going from negative to positive. From negative to positive. And so it's choice D. D is the best choice because it looks like it's curving here. It looks like it might be going negative again. Same thing here. It looks like it's curving. It might be going down. And so this is my best choice because all the way to the left, it looks like it might be going down. Right? It looks like it might be changing. Same thing to the right. It looks like it might be changing. And so D would be my best choice.